Hi everyone, and welcome to one more episode of the Allplane Podcast, where we talk with the movers and shakers that are redefining the future of commercial aviation. As usual, before we start, I would like to remind you that all previous episodes of this podcast, as well as many other aviation stories, are available on the Allplane website. That's Allplane.tv, Allplane.tv. And you can also subscribe to the newsletter, which I send on a pretty much weekly basis with lots of interesting stories about innovation and sustainability in the aviation industry. And now to today's episode. Our guest today is one of the, let's say, heavyweights of the advanced air mobility scene. Daniel Wiegand is the co-founder, chief engineering innovation and board member at one of the largest, most advanced and potentially most disruptive eVTOL developers out there. I'm talking about Lilium. What sets Lilium apart in this emerging but very, very competitive industry that is advanced air mobility is not just a super cool design or its ducted fan technology, which is also pretty cool, or the more than $1 billion raised since its inception. What I find really interesting about Lilium is its market approach. Because rather than position itself as an, let's say, air taxi provider or urban air mobility provider, Lilium is targeting the regional transportation market, which can be a pretty massive market. What's also quite impressive about Daniel's story is that he actually started this company pretty much out of university, and he didn't do it in Silicon Valley, but in Germany. So today, Lilium is approaching the final stages before its Lilium jet, such as the name of its eVTOL, is certified. And actually, it has already built its first production aircraft. I actually had the chance to see it with my own eyes during a recent visit to Lilium's HQ near Munich. And by the way, when I was there, I also got a chance to try the Lilium jet simulator, but that's maybe a story for another day. So today, with the Lilium jet already undergoing flight testing and becoming ever closer to becoming a tangible reality, we are going to review, together with Daniel, the short but very intense history of Lilium, the main characteristics of its eVTOL aircraft, the Lilium jet, and why it's supposed to be such a big deal for the advanced air mobility industry. So I think it's best if we hear it all directly from Daniel. Without further ado, let me welcome him to the podcast. Hello, Daniel. How are you?
Hi, Mikael. Very good.
Thank you so much for joining us here on the Allplane Podcast. I just will make a very brief introduction about who you are and about Lilium, which I think is one of the most interesting projects that are taking place right now in the field of advanced air mobility, basically developing the Lilium jet, which is going to provide regional air mobility with an all-electric aircraft that looks absolutely science fiction. It's not fiction, it's a tangible reality already, but it looks like something that comes out of one of those 1960s cartoons where they imagine how the 2000s would be like. But first of all, let me ask you a little bit about yourself, about how you started Lilium. You're one of the co-founders of Lilium, and I think you're now the Chief Innovation Officer at Lilium. And I would like first to ask you, basically, to tell us a little bit more about how all these projects started, and also, what's the origin of this story?
So I'm a trained aerospace engineer by background, and I was always fascinated about aviation since I was a little kid. And during the end of my studies at the Technical University in Munich, I had this idea that while watching a YouTube video, that combining the capabilities of the electric powertrain and emission-free, it's low maintenance, it has a very high power density, it's low cost in operation. By combining these advantages with a new configuration with distributed electric propulsion, and the vertical takeoff and landing capability, we could basically create a wonderful regional means of transportation, which is emissions-free, very fast. It would be low noise compared to today's aircraft and helicopters, and it could therefore, at low cost, enter into urban environments. And this was sparked by watching some videos on YouTube, and then I started doing some first calculations, more for fun. And later, one of my flatmates at the time inspired me to actually found a company to do this, because he said, if it's physically possible and you're not going to do it, no one else will. And that was a very simple and naive view, but at the same time, I think it proved to be true to some degree. And I'm very happy that we did.
Are you telling me you started Lilium just straight from university?
Exactly. I was actually in the master thesis and finalizing my studies when my three co-founders and myself established the legal entity for Lilium. That was in 2015. And then initially in the first year, we bootstrapped the company, building some prototypes together with interns and other students. And after about 9 months, we had our first seed investment. And from there onwards, over multiple rounds, built the company. I was the CEO for the first 7 years, growing the company then up to 800 people and raised $1 billion, and NASDAQ listed the company as well. And it's been a great ride so far.
Wow, that's pretty impressive, because, I mean, creating a $1 billion startup listed in the NASDAQ out of university, that's pretty impressive. But in hardware and in aerospace, particularly, that's even more difficult because of all the, obviously, all the technical and regulatory challenges that are along the way. So yeah, pretty impressive. So right now, Lilium is a tangible reality because you have a flying aircraft that is in test already, and you have an entry into service expected when? The next couple of years, if everything goes all right?
Yeah, the targeted delivery to the first customers is in the second half of 2026. And as you just said, we've done about 5 generations of demonstrator aircraft to demonstrate the technology works. We have flown for roughly 5 years now, full-scale airplanes in Spain, where we have a flight test center with 2 aircraft dedicated to just testing the technology. And this has enabled us to really find a lot of challenges, mature the technology, develop the software to control the new configuration of the aircraft. And then in the end of 2020, we started with the development of the serial product, because we felt we're now mature enough. We know the technology is working. And since then, we have developed the serial aircraft, which is now, since the last winter, in production here. We have by now 2 airplanes in the final assembly line, the third one starting soon. And we're targeting then to do the first piloted flight for the certification in the early of next year.
Very good. So yeah, it sounds, as I said, when you see the Lilium aircraft, the Lilium jet, it really looks very futuristic, but 2026 is just around the corner. It's going to be really a thing to see this thing flying overhead. I have seen this aircraft. I've been to your facilities near Munich, had the chance to fly the simulator as well, which was really cool as well. Quite an intuitive type of cockpit, I would say. It really felt like something that,
This is one of the big advantages of the technology. It's a full fly-by-wire airplane, all software controlled. It has just 2 functions. One is spin the fans, and the other one is change the angle of the fan. And with those 2 degrees of freedom, we are controlling the aircraft in all states of flight, in the vertical takeoff, in the transition, and in the cruise flight. And this makes it mechanically very simple, also makes it lighter, which gives us a better performance. And it's for the pilot, the advantage is that you have fully decoupled control axis. So it would always do exactly what you command on the joystick. And that makes it very simple to fly, for example, compared to a helicopter. And of course, also safer. And everybody right now is laser focused on this final assembly and the first flight and the commencement of the certification test campaign in the flight testing. And here I think we are really in a unique position right now from a global perspective, because the European regulator, EASA, they have established a complete and comprehensive set of requirements for these airplanes already in 2020. Meanwhile, they have also established the regulation around operations and pilot licenses around the airplanes. And this has enabled us to move forward and press forward and develop a certification conforming aircraft, which we are testing now. And that's, of course, a very big difference between testing a technology demonstrator, which just needs to physically function, or testing something that is produced in an aerospace supply chain with all the quality management, the full traceability that was designed according to the aerospace certification process. And then it's being assembled and tested as a certification aircraft. And here we are, I think, in the winged eVTOL segment, globally leading with respect to that certification timeline.
I think at this point, it would be perhaps useful for the audience to move one step back and let's look at the actual product, at the Lilium jet, because I'm sure many people have heard about Lilium, particularly people that listen to this podcast, which are, I assume, interested in aviation, but they might not be necessarily familiar with the characteristics, particularly in this space where there are right now so many competing projects being developed in parallel, each one with its own unique features. How would you describe it? I know it's a bit difficult. I'm going to post some pictures on the show notes so that people can get an idea of how it looks.
So the Lilium jet is the largest electric vertical takeoff and landing aircraft, which is currently in development. It can carry 6 passengers and 1 pilot. It's entirely battery powered, and the propulsion system is using electric ducted fans or electric jet engines. And those have the advantage compared to propellers that we can achieve a higher wing loading, and they're more efficient in cruise flight. They also have lower vibrations and noise emissions compared to propellers. So from a customer perspective, the difference is very similar to a jet airliner or a turboprop aircraft, which is why most customers prefer this technology. We have picked this technology for the customer advantage, but also because it enables us to achieve better economics by having more passengers on board and by flying faster in our long-range missions. And this comes from the business model we're targeting. We're targeting a regional business model. And this is in contrast to the classic air taxi segment. So there's when people speak about urban air mobility or air taxis, they typically look at an on-demand flight, which is maybe 10 or 20 miles across a city. And our aircraft can fly this mission. But when we looked at this market 6-7 years ago, we realized that the size of the market is much larger if you go into regional distances, because the time saving you can create for your customers is very quickly in hours of time saving. Whereas if you do a 10-mile flight in a city or urban environment, you always have to count in the taxi trip to the vertiport, the switching the aircraft, the taxi trip from the vertiport. And if you add it all up, the time saving in most cases is not worth the switch into an aircraft. So this is why we have always been focused on regional aviation. And this is also where we see the big demand of our customers. We've never had a customer saying, can you optimize for the 10-mile mission? All the customers we're talking are asking, when are you exceeding 200 kilometers range? When are you exceeding 300 kilometers range? Because that's really where they see the application and the market. And here we have the only product globally which can carry 6 passengers over those distances.
So the distances, you right now, the current production model, which range are we talking about? 175, 200 kilometers, something like that?
So with the battery cells we have in production right now, the aircraft can achieve around 175 kilometers operating range. So the actual range is longer, but you have to subtract reserves, of course. Yep. And the great thing is that the aircraft is designed in a way that you can replace the battery packs without changing the airframe. Mm-hmm. And that means as the batteries are improving at a rate of 6 or 7% every year in their energy density, we believe that we can offer every 2 or 3 years an upgraded battery pack to our customers. And this way they can probably by 2030, 31, they'll be able to fly between 250 and 300 kilometers operating range. And one of my jobs right now as Chief Innovation Officer is to work with our suppliers and technology partners on this battery roadmap and making sure that we have this continuous pipeline of improvements to the range of the aircraft. And the great thing here is that in today's battery pack, only 50% of the energy stored in the battery is being used for the cruise flight. And the rest of the energy is mainly reserves for safety reasons and to some degree takeoff and landing energy. And those buckets, they stay the same regardless of the size of the battery, which means every improvement of the battery goes into the cruise flight segment of the aircraft. And therefore you get a non-linear increase in range. If you get 50% more energy in the battery pack, we can almost double the operating range of the aircraft. And that shows that right now, the battery technology is just on the edge in terms of enabling this type of a product and of an aircraft. But if we fast forward by 5 years, you can achieve a massive range of maybe 300 kilometers. And that's more or less covering 95% of the market in which helicopters are being used today.
You touch upon an important point, I think, that links a little bit the technical and the business side of the project, which is you plan to offer this to regional air mobility operators. But as you know, there's also a number of other startups that are targeting this regional air travel market with a more conventional, quote unquote, technology, which involves eSTOL, short takeoff and landing, using small airfields, but still using a conventional takeoff and landing, as opposed to what you're doing, which is vertical takeoff and landing. I mean, do you see Lilium jets operating from more centrally located waypoints or gateways? Or you are also looking at, let's say, a more traditional model where people go to an airfield and take off from there. What would be your response to people that compare the Lilium jet with these other also electric aircraft, but that operate on a more traditional operational profile, let's say?
Yeah, so in the end, you need both. What you are optimizing for is always the shortest trip time. And what we're seeing is that up to a range of 300 to 400 kilometers, your total trip time is usually shorter if you have a vertical takeoff and landing airplane, because your takeoff and landing sites will be very close to your target destination. And that means for cities like London or so, you're not spending time in traffic to enter the town, but actually you are landing in the city. So this is the application we are looking at. And here we can very quickly achieve hours of time saving on many intercity trips. If you want to fly more than 400 kilometers, the better application is to use a pressure cabin aircraft with conventional takeoff and landing, because it flies at twice the speed or 3 times the speed of the VTOL. And therefore you can afford spending more time getting to an airfield and having a larger aircraft, which means you are bundling more passengers in one flight, but you're flying a further distance and you're flying at 2 or 3 times the speed. And this is actually part of Lilium's company vision and mission. We never saw ourselves as an urban air mobility company or as an urban air mobility limited company. We see ourselves as an electric aviation company, and our mission is to bring this electric powertrain technology into multiple segments in aviation, all the segments where it makes sense. And one segment is from 0 to 300 kilometers, the vertical takeoff and landing jet. But from 300 to 2,000 kilometers, our target is, as a next step, to develop about 80 to 100 passenger electric airliners with pressure cabins, conventional takeoff and landing, which would fly those distances. And here we have done quite a lot of pre-work and studies to transfer the technology from the VTOL jet into those larger aircraft. And what we're seeing is that if you develop such an aircraft, let's say you start in 1 year and you're going to certify it maybe then in 33 or 35. By that time, the battery technology will enable us to fly roughly 1,000 kilometers operating range with such an aircraft. So any domestic European country flight would already be possible to be done electrically. And about 10 years later, we think we can achieve around 2,000 kilometers with such a battery electric airliner. And that doesn't sound like so much, because we have airliners today flying 15,000 kilometers. But if you look at the statistics, with 2,000 kilometers, you can cover 80% of all commercial flights today. and about 50% of all passenger kilometers flown today. And that means with this electric technology, we can basically electrify 50% of the global aviation. And that's the mission we see as for our company. We're today Europe's largest electric aviation company. We're globally the second largest. And our mission is to electrify all of regional and short-haul travel.
Would you say that the ducted fan technology that you use is let's say, one of the differential points that you have in this space?
It is one of the differentiators, absolutely. But I'm a propulsion engineer by background, and we're agnostic to the technology. We always come from the business model and the mission, and then we select the best technology. And this goes across from the aircraft architecture itself, which needs to be suited for the mission, to the propulsion system and the battery technology you are choosing. We can play in a very broad spectrum here based on the technology we have in-house and also the team's capability.
I would like to stop 1 second now, 1 minute or a few minutes on the technology side, because I found this ducted fan technology quite interesting. So can you describe in more detail how it works? From outside, just a very rough description is basically you have these propellers that can be shifted from one position to another. So a bit like, I don't know if that's a fair comparison, but the way the Harrier jet achieved its vertical capabilities by directing the energy horizontally or vertically and going up and down. But can you tell us a bit in more accurate words that I'm using here, how this works?
Yeah, happy to explain. So it works in the principles, it works in the same way like today's turbofan engines. Mm-hmm. If you have a large turbofan engine with a high bypass ratio, you have in the center a gas turbine, which is not making a lot of thrust, but it mainly makes torque that drives the main fan in the front. And this fan in the front then produces 90% of the thrust. And in our case, it works in the same way, but we are replacing that gas turbine in the center with an electric motor that drives the fan. And mm-hmm. the advantage here is obvious. You have no emissions, you have a higher power density, you have reaction times in milliseconds. You can adapt the RPM of the system to control. And it only has a single moving part. So the complexity basically collapses compared to a classic gas turbine engine. And this is how the engine works and makes thrust. And in the second step, the way we are controlling the aircraft is by tilting the engine or changing the angle of the engine and therefore changing the thrust vector of the nozzle. This is close to the Harrier. In case of the Harrier, they are keeping the engine fixed in the fuselage and they're changing only the angle of the nozzle. But for an electric engine, tilting the angle is no problem because we anyways don't have any oil circuits. We don't have any variable pitch mechanisms also. It's an incredibly simple technology. And that's also the beauty of it. That's what makes it attractive for operators in terms of reliability, in terms of safety, in terms of cost.
Yeah, I was wondering because obviously the electric engines, one of the advantages is the simplicity, but I was wondering how much of added complexity did this tilting mechanism bring to the system? I mean, we know like some tilting rotor aircraft that exist, that have been developed, have been notoriously complicated to develop because of all these, the complication of this mechanism. But apparently, from what you tell me, it's not the case here. You have found a way to make it simple.
Because there's basically zero similarity between the two. So if you look at the tilt rotor aircraft, these are the most complex machines mankind has built, I would say, in terms of you have two helicopter rotors, which are already mechanically very complex. You have flapping, you have the angle adjustments, a variable pitch of the blades, etc. You have all the rotor dynamics. You then have the gearboxes, you have the tilt mechanism, you have the coupling gearboxes from one nacelle to the other. We have none of that. We have just one moving part on the electric motor and fan side. The fan is one bliss, so no blade adjustment, nothing else. And we have no gearboxes, no oil circuits, and just a redundant tilt mechanism. So we have a total of 30 engines, and always two engines have one tilt actuator, which also means we don't need cross couplings or gearboxes between them. if one of them fails, we have enough redundancy to continue the flight and do a safe landing with the remaining ones.
Yeah, 30 engines. That's actually also very remarkable. And actually, I think they've been reduced from 36 originally. Why is the need for so many engines acting in parallel?
There's no need for so many engines. There was an advantage in performance. So technically, you can do vertical takeoff and landing with 6 engines only. And if you then have one failure, you need to switch off the opposite engine and you would still hover with the remaining 4 engines. But if you do this, then you have engines separately hanging under the wings, for example, like you've seen it in airliners today. And what we have done is, because of the ability of an electric engine to be independent in its efficiency, it's independent of size. You can make also multiple smaller engines and they will still have the same efficiency. But because of cooling improvements, they have a tendency to get even lighter if you make them small. So what we have done is we have broken down the 6 large engines into 30 smaller engines. And the advantage here is that we can then embed those small engines on the trailing edge of the wings. So exactly where you normally have the control surfaces in the wing. And this allows us to basically replace part of the surface of the wing, and that reduces weight and drag of the aircraft in the first place. But it also allows us to remove the aerodynamic control surfaces and those actuators and control systems, because when the engine is in that position, we can use the nacelle surface to create the same aerodynamic control forces in the cruise flight, which you would normally create with the control of using your ailerons and elevators, etc. Mm-hmm. So overall, this saves us a lot of weight and complexity on the aircraft. And since we anyways need that tilt mechanism for the vertical takeoff and landing, why not also use it for controlling in cruise flight?
Mm-hmm. Yeah, actually, I wanted to ask you about the hovering stage, because from outside, I got the feeling that this might consume a huge amount of energy. Which sort of energy density have the batteries that you're currently using? I know that, as you mentioned, this could be upgraded over time, but right now, what sort of technology are you using for the batteries?
Yeah, maybe one comment at first on the requirement. It's a common misconception that vertical takeoff and landing would consume so much energy. In our case, if we look at a 170-kilometer mission, we're consuming about 9% in takeoff and landing and the early transition flight to accelerate the aircraft. So 9% of the mission energy is this portion. And if it were a conventional takeoff and landing, it would still be 3-4%. So it's not that much of a difference. The batteries we're using are comparable to premium electric car batteries at the moment. So they're using about 320 watt hours per kilogram on cell level. They have a low internal resistance, which allows us to do a fast charging and also to draw those high power pulses at takeoff and landing without generating a lot of heat.
What about the technology for the battery? I think you are producing your own battery packs in-house. So you take the battery cells, you produce a system. What can you tell me about the technology, energy density, and the projects you have in this field?
So yes, the battery packs we are developing and producing entirely in-house. And here the focus is a lot on the safety compliance, and also the lightweight design of those packs, but also that we can produce them at low cost and enable replacement of those packs at low cost to make sure that they fit into the interface in the future. The battery cells we are buying from our suppliers. They are currently in production at Custom Cells here in Germany, where they have a dedicated production line for our cell format. And this means we can really tailor from the chemistry to the mechanical cell design and dimensions. We can tailor those cells to perfectly serve the mission we are targeting with the aircraft. If you look into the chemistry, it's a very classic lithium-ion chemistry using an NMC cathode and an anode with a high silicon content. And this is what gives you the fast charging capability and also the increase in power density. And this is very comparable to what you find in the latest premium automotive cars with very long range and fast charging capabilities.
What sort of energy density are we talking about at the moment?
We're talking about, in the first generation now, about 320 watt hours per kilogram on the cell level energy density. and the power capability of the cell is around 5 kilowatts per kilogram. So it's a very high power capability as well.
What about the pack level?
On pack level, yeah, this is depends on everybody counts different components into the pack. You can assume that those values are reduced by 20-25% on pack level.
Mm-hmm. Let's maybe move on to the business case here, because my understanding is that you are betting strongly first on obviously the regional air mobility, but who's going to operate that? Is it going to be existing executive jet operators? Is it going to be new generation operators that spring up to take advantage of all this new wave of innovative aircraft that are expected to come into the market in between the next 5 to 10 years? Or I think at some point you were even considering operating your own aircraft. I don't know if that's still the case, or this project has been shelved in favor of becoming a pure OEM and letting others do the flying.
Yeah, the business model is very simple and straightforward. We are a classic aircraft OEM selling the airplanes. This is the main column of revenue. We're not operating the aircraft. We had intended to do this in the past, but we realized that this is not our strength. It's also not very effective to try to be competitive globally in operating this product. So we're entirely focused on delivering the best aircraft to our customers. This is our strength. And in a second step, perfectly supporting our customers in their operations. So we're targeting a quite large services business. And here, especially, the revenue is driven by the replacements of the battery packs. So you can do roughly 2,000 flights maybe with one battery pack. And if you have an airline operation with maybe 7, 8 flights per day, you have to replace the battery pack roughly once per year. And this second column of revenue drives almost 50% again of our revenues in the future business model. And that also enables us to have a relatively stable revenue, because as long as by being in the printer and cartridge business, basically, as long as the fleet is in operation, you also have revenues from those battery packs. And of course, the customers also want upgraded battery packs with more range over time. So very simple business model with which we are targeting two customer groups. The first one is in the premium sector, where we have around 50% of our pre-orders at the moment. And this means the aircraft is in the application of replacing executive helicopters and replacing the very short business jet flights. So we're hearing from business jet operators, for example, NetJets, that around 20% of their flights are less than 300 kilometers. And those can be, of course, made environmentally friendly. They can be much less costly, and they can be shorter in total trip time if you use a vertical takeoff and landing jet, which is being certified at the same safety level like an airliner. So we can often even increase the safety level, but especially compared to a helicopter, it's a safer product. So you have a lot of advantages here in the premium segment from shifting. And we're at the moment the only product which is on offer in this premium electric regional aviation segment. And then the second target market, which is by far the larger one with 80-90% of the global market size, is the classic shuttle market or airline operations, where you have airlines which are operating this aircraft either as a feeder flight into their existing products or in a direct city-to-city connection. And those airlines, of course, are also targeting then over time to increase their electric fleet step by step as batteries are improving in performance.
My understanding is that you've got one aircraft type, but it comes in two flavors. I mean, you have the standard one, then you have a more premium version that's going to come in a limited edition. Is that right?
Yeah, it's always the same airframe, but we're offering the aircraft with different cabins. There's a premium cabin with 4 passenger seats, which is, you can compare it to a classic business jet or a business class, where you have a lot of space. You can have additional monuments in the cabin. You can freely customize the colors and the layout. You can have a bar there. You can have other tables and other monuments. And then in the airline configuration, you have 6 passenger seats, which is comparable to a premium economy seating. But here the focus is clearly to reduce the seat mile cost, and it enables us to achieve in the airline operations a final ticket price of around $2 per passenger kilometer, including the airline margins. And this shows it's a lower price than a taxi here in Munich. And that shows how competitive this product actually is in transportation.
$2 per passenger per kilometer transported.
Exactly. Yeah.
Wow, that's pretty ambitious, I would say. Does it take into account any potential landing fees,
It
everything?
takes into account everything: insurance, landing fees, pilot cost, load factor of the aircraft, airline margins, battery replacements, maintenance, etc. And it's the result of years of continuous optimization of the product, as well as the business model and the aircraft capacity to achieve those low seat mile costs, because this is what unlocks that large global airline market.
Mm-hmm. And how much does it cost to buy one of these jets? Sorry, Lilium jets.
So depending on the package and support package around, it's between 7 and 9 million.
Per aircraft.
Yeah. And we have a total order book of about $6 billion, around close to 800 aircraft at the moment, of which more than 100 aircraft are firm contracts. And here we are also globally leading with the number of firm contracts. And this is what really matters for us, because those firm contracts means we're committing performance to the customer, operating costs, we're committing a production slot and the price, of course. And in return, those customers are committing to a pre-delivery payment plan to us. So there's some payment upon signature. And then based on milestones in the program development, such as the first flight or certification of the aircraft, there are additional payment milestones for these contracts. This is an important element of financing the program development cost in the last year. And even right now, it's contributing to financing the development of the aircraft.
Yeah, I wanted to ask you about this because in the last year, there have been some concerns about the burn rate. Obviously, this is a very capital-intensive business. It's still about, in the best case, 1.5 years away from entering into service. What is currently the financial situation? I know you recently raised another round, I think over 115 million or even more, just quoting from memory here.
We raised a round of roughly 115 or so, 114 about 3 months ago. But it's known in the market that we are working on raising additional capital. And this is basically coming from 3 different angles. One is the pre-delivery payments, which I just described. The second one is that we are working with different states. For example, Germany and France, we have announced we're working on loans, which are supporting the program. And here we are quite far progressed in both countries with respect to the details of the process, the approval process, etc. And the third bucket is the classic financial market, where we're looking at also loans and some equity raises. And in combination, we can fund the program over the next 2 years then until we have the first customer deliveries.
So these 800 aircraft, when operators place these orders or pre-orders, I don't know what's technically the right word, they already placing a deposit to get the right.
Yes.
And in terms of industrial production, to deliver all these 800 aircraft, what's the industrial plan? Right now you have the main facility in Germany, in Bavaria, near Munich. You have a test site in Spain, in the south of Spain. I think you also signed recently an agreement in France to develop your activities there as well. What's the industrial plan when you get to certification and it's time to get all these 800 plus any other orders. What's the production rate that you envisage going forward?
We have recently invested quite strongly into the German plant, where we have around 160,000 square foot of manufacturing facilities. And this is required because you need to produce the certification conforming aircraft in the same processes and quality environment like your serial aircraft. So we have built a small serial production line here. And the space we have available here allows us to go up to a rate of around 80 aircraft per year. And from there onwards, of course, we plan to grow with additional plants. So one of them is France, which you just mentioned, and the loan we are negotiating with the French government is also dedicated to finance this additional facilities in France. And from there onwards, long term, we are expecting to have at least one factory in the US, one in China, maybe two in Europe, maybe one in Middle East. So we want to make sure that we are close to the customer. And we think that in terms of efficiency of those final assembly lines, there's kind of a plateau. So if you go, let's say, beyond about 400 aircraft per year, it doesn't make that much sense to bundle this in one plant. You would rather have a plant in a different continent so you are close to the customer.
Mm-hmm. You mentioned the Middle East. You recently got, I think, as recently as this summer, you signed an order with Saudia, the airline of Saudi Arabia, for 100 aircraft, which is a significant portion of your order book. As you know, there's been also other advanced air mobility developers that are investing heavily in the Middle East, which is shaping to be possibly one of the first places in the world to see eVTOLs in active, real-life commercial service. What are your plans for the region? Do you also see the Middle East as a sort of launch pad for your activities, for the debut of your aircraft?
Yeah, we see a lot of momentum in the Middle East, and therefore we clearly see both for eVTOL, but also in general, there is Vision 2030 in Saudi Arabia, for example, and there's a mindset to really develop quickly. And this is why we think that Middle East will clearly be one of the launch regions for eVTOL and advanced air mobility in general, not just for us. But I think the contract you mentioned from Saudi is a great example. It's the largest binding contract in the eVTOL segment globally. And it shows the approach we're taking. We have a lot of players in Middle East signing MOUs and announcing they're operating 4 aircraft there or so. But we have partnered with the strongest operator in the region. And they clearly looked at the segment and said they think this is by far the best suited product for their application because of the regional capability, because of the large cabin capacity, and also because of the low operating cost they can achieve with this aircraft and the high capacity. So this is a great example, but we're not stopping there. We have a partnership with GACA, the regulator in Saudi Arabia, to make sure that we have the regulation in place. We're working with other players in the region on infrastructure. We're also working on some bringing maintenance and some operations locally to where the customer is, and basically benefit from that growth, because we're hearing from customers in that region, they're seeing a market for more than 1,000 Lilium jets in Saudi Arabia alone. And here we're not yet speaking about Dubai and Oman and other places in the region.
Wow, 1,000 aircraft. And what about Europe? What country or market do you envisage as being among the first to adopt this technology?
Yeah, Europe is currently globally leading with respect to the regulation on eVTOLs. And we are also based in Munich, in Germany, in Europe. And that means we clearly see that Europe will be on the forefront of implementing urban air mobility and electric aircraft. And we also have the customers. We have 30% or more of our customers coming here from Europe. One of the launch regions clearly will be the south of Europe. And one of the examples here is south of France, where we already have a very high density and a big market for helicopter operations.
Yeah, indeed. I can say this summer I was in the Côte d'Azur, and the helicopter traffic was constant all the time along the coast. So I'm sure, yeah, that there's a need for a quieter type of aircraft
Absolutely.
operating in this type of areas. Just to wrap it up, what's the next milestone that you are aiming for at the moment? Obviously, you have, according to the plans, a pretty close certification and entry into service expected date. But are there other milestones that we should be looking for in the meantime?
So there's clearly a couple of important milestones coming up. The first and most important one that is very soon is the first flight of the conforming aircraft, the first piloted flight. Then there will be, of course, some commercial milestones with further commercial contracts and expansion. There'll be some funding milestones, agreeing on the previous the loans and other funding milestones I had mentioned before. Those are clearly the most important ones.
Excellent. For people that wish to learn more about Lilium, are there any resources that you would recommend? What's the website, for example, or social media channels that you are using to share all these exciting news?
Yeah, of course, I would always recommend the website, but if you go into the link section of the website and you want to go a bit more deeply, we have some nice blogs and video webcasts about, for example, battery technology, about certification, etc., which is a great way of learning more in the details of how such an electric aircraft is being developed, how it functions, how it's being certified and industrialized.
Yeah, and actually, there's one point that we didn't really mention, but I think it's also pretty relevant in the case of Lilium. It's the design, because you've got a design that I think it's pretty unique, very eye-catching, and I'm sure it's gonna be a head turner wherever this aircraft first appears. It's gonna make massive headlines because of not just the function, but also the looks of it.
Yeah, there's a saying in aerospace that if it looks good, it flies good. So if you look into the exterior design of the aircraft, this is all engineering surfaces. So it's really an aerodynamic function which this design is serving. If you look into the cabin, of course, our product designers have done an amazing job in making the cabin a place that feels like a place where you want to spend a lot of time.
Indeed, I had the chance to be inside some of the real size mock-ups that you have been displaying at air shows like eBay, and it's really, really pretty amazing. I'm going to be posting some of my own pictures that I took inside that cabin, so for everyone to see. But well, in the meantime, just left for me to thank you very much for your time today and for sharing so many details about Lilium. And yeah, we'll be all looking forward to hearing further news. Who knows, new orders, the first flight that you mentioned. So thank you so much.
There's always news, and yeah, many thanks, Michael, and thanks to everyone listening in.
Thank you. If you like this podcast, you can support us by giving it a great rating on Apple, Spotify, or whichever platform you get it from. And remember, you can of course subscribe to it. And you can also get regular updates through the Allplane website. That's Allplane.tv. We have a newsletter where we cover the aviation industry every week with a special focus on innovation and sustainability. So give it a go. Thank you and goodbye.